Today we will discuss about potential divider circuit. So first we have a circuit, and on one side we have the maximum voltage, on the other side the minimum voltage, and our goal is to vary the potential at B. We have a variable resistance R and a fixed resistance, say 50 ohms. Now let's calculate the current through this wire. So by the formula V is equal to IR, we could get current I is equal to V by R. So the potential across this wire is, potential difference across this wire is 5 volt. So 5, and total resistance through which the current passes, the current goes through this and this, right? So total resistance through which the current passes is R plus 50. So this is our current through this wire. Now let's find the potential difference across each of the resistances. So to find the potential difference across this, again we will use the formula V is equal to IR. So resistance is R is 50 and I, as we found, this is I. So we'll use both these to get V. V across 50 ohm is equal to I multiplied by R. So that's our potential difference, and we could also write it as 5 into 50 by R plus 50. And across R ohm will be, again using V is equal to IR, I is again 5 by R plus 50, and resistance is R. Let's write it as 5 into R by R plus. And another very important thing which I want you to notice is that the potential difference is proportional to the resistance. That means across 50 ohm it is 50 by R plus 50, that is the total resistance, and this is the potential difference across 50. That means in proportion to the resistance we have the potential difference. So 5 is the total voltage, and across R resistance it will be R by R plus 50 into, it's a partial fraction of the total voltage. Again 5 is the total potential we have, and across 50 ohm it's 50 by R plus 50. So that's a very important fact. And another awesome thing is that across 50 ohm we found the potential difference as 5 into 50 by R plus 50, and this will be exactly the potential at B. We wanted to find the potential at B, right? So the potential across 50, as we found, potential difference across 50 is 5 in this thing, and since on one side we have 0, on the other side it is obviously the potential difference we found, 0 and this. So we found the potential at B. Potential at B is 5 into 50 by R plus 50. So now what's the implication of these things? So first of all, let's see if R is 0. If R was 0, then we could see that here if we substitute R equal to 0, we'll get potential difference across R ohm to be 0. So potential difference across R ohm will be 0. That means if it is 5 volt here also it will be 5 volt. So at B it will be 5 volt. So that means no difference between the potential on both sides of R. And if the resistance R is very large, let's say it's almost equal to infinity, then if we substitute R to be infinite, it will be R infinite by infinite plus 50. That means as R increases, this value will reach towards 1, tend towards 1. That means the potential difference will be maximum. That is 5 volt. So what does that mean? So that means potential difference will be 5 volt across R. So if it is R, it's 5 volt here, and if for the potential difference to be 5 volt, here it should be 0. Let's substitute infinite here too. If we substitute infinite for this potential difference, we'll see that 5 into R by infinite, which is equal to 0. So across 50 ohm, the potential difference will be 0. That means here also 0 volt, here also 0 volt. A very fun way which I like to look at this thing is, I like to see the resistances as potential eating monsters. And what does that mean? So the potential starts coming from here, and these resistances are potential eating monsters. So if the monster is very large, it will eat a very large part of the voltage that is coming, and if the monster is small, it will only eat a small part of the potential that is coming. So if 5 volt is coming, and if R is very large, then it will eat the entire voltage here, and the potential at B will be 0. And if the resistance is very small, then it won't eat much, so most of the potential could pass, and at B also it will be 5 volt itself. So that's potential divider circuit. So what's the use of it? You could see this thing is pretty much like the diagram I drew. So if we connect a 5 volt to this wire, a 0 volt to this wire, and if we connect it to something like Arduino's analog pin, and if we vary this resistor, that is exactly like varying this R. So the potential at this wire goes on varying as we vary this this plug. So we could use it in further Arduino programs and Arduino projects.